In this lesson video, we're going to cover color models. Now, I warn you guys that this lesson and the next one will be theoretical. And if you want to skip ahead, you can do so without any problem. But if you stick around, you may get some additional insight about how color works in the real world and in computer graphics. It will be beneficial later if you need to work with graphic application outside Blender. Color is one of the most important aspects in creating beautiful art and design. There are so many colors and color variations exist in the world. For centuries, we as humans have tried so hard to uncover the secrets behind colors. Why is this so important for us? Because by knowing how colors actually work, we can later capture them, store and digitize them, reproduce them or display them precisely. We need to simplify the colors to its basic components, which are called the key colors. Using the combination of these key colors, we can reproduce any color that we want. This is what we call the color model. So basically, color models are methods of describing colors using a combination of key colors or using a set of parameters. There are at least two types of color model that we need to know as an artist or designer: light-based color models and pigment-based color model. Light-based color models use lights as the color producer. All devices that produce light use this color model. For example, our computer monitors, smartphone screens, television, projectors, etc. There are two light-based color models we're going to discuss in this lesson video. They are RGB and HSV. Okay? Unlike the light-based colors, the pigment-based color model use inks or paints to produce color. Everything that is printed or painted use this color model. The pigment-based color model we're going to discuss in this video is CMYK. Let's discuss the light-based color models first, and then later the pigment color model. RGB, as I mentioned before, is the color model for lights. RGB stands for red, green, and blue. Using these three key colors, we can produce any color we like. If all of the colors, red, green, and blue, all turned on to its maximum strength, the output color will be white. And if none of the RGB colors are turned on, then the output color will be black. So basically, in RGB color model, black means off or no lights at all. If only red and green color turned on, the output color will be yellow. If green and blue are turned on and the red is off, then the output color will be cyan. If red and blue color are turned on while the green color is turned off, then the output color will be light purple color. If the strength of each channels are uniform, then the output color will be grayscale colors. Other colors can be produced by controlling the strength of each channel. Okay, so that is RGB color model. Now, although RGB is the true color model of lights, using RGB to pick color is very unintuitive. If we need to select certain color, we need to do a lot of guessing and try and error process. That is why a new light-based color model was introduced called HSV. HSV, which stands for hue, saturation, and value, is the derivative color model from RGB color model. It is light-based color model also. But unlike RGB, which divide color into three main colors, HSV use color characteristic instead to define the color output. First is hue. This hue strip will display the color wheel. It is called the color wheel because it actually a rotational value from 0 to 360 degrees. We can see that the red color in here is actually the same with the red color in here. The saturation value controls how much color present as opposed to grayscale colors. If we set this to maximum value, the color will be at the strongest value. And if we set this to 0, there will be no color at all, or basically makes everything in grayscale spectrum. Changing this saturation slider is the same as dragging the color pointer up here, left and right. The V slider in here is for value. In other software, sometimes it is called B, which stands for brightness, or L for level. So basically, HSB and HSV and HSL are actually the same thing. The brightness value controls how much light is being emitted from the color. Changing this value or brightness slider is the same as dragging the color pointer up here, up and down. If we set this all the way to 0, we will have black color, because in light color model, as we mentioned earlier, black means dark or no lights at all. If we set this all the way up, the color will be at its brightest. The third color model is CMYK color model. Unlike the two color models we've discussed earlier, CMYK is pigment-based color model. If you own a color printer, most likely you're already familiar with CMYK because the ink cartridges of color printer are based on this color model. Long time ago, we used to think that the key colors of pigment or paints are red, blue, and yellow, because a lot of colors can be produced by mixing these three colors. Some art schools even still teach these concepts until now. Although you can achieve a lot of color variations with red, blue, and yellow paints, you cannot produce all of them. Scientists already discovered that pigment's key color are more likely to be CMYK. C for cyan color, M for magenta color, Y for yellow color, and K, well, K is actually stand for key color. But because most key colors are considered as black color in printing industry, we can safely assume that K is for black. We need black color as cyan, magenta, and yellow colors when mixed together can only achieve brownish mud color. They can never achieve black color without a dedicated black ink. In this course, because we are focusing on creating game artworks, we will never need to touch CMYK color model. Why? Well, as we all know, video games are always be displayed on screen, whether it be TV or computer monitor, or tablet screen or smartphone screen, etc. They are all use light-based color model. That is why also in Blender or Unity, you will not find CMYK color picker like the one you can find in Photoshop.